Okay, I'm currently testing and evaluating the Alps digital encoder that's used in the multi/CH location of the TS990. What you see here is a product made by a different company called Bourns. And you can just take a look at what I've done. I've connected the encoder into a drill. And this drill is set rather high. It exceeds the rating of the switch. But I've been running it for quite a while so far. And as you can see from the scope, we have 140 hertz waveform. That translates, this Bourns switch has 20 detents and consequently 20 matching contacts per rotation. So 140 hertz comes out to about 7 revolutions per second. That exceeds the rating. Bourns recommends you don't exceed about 1 revolution per second. Having said that, I'm going to leave it run until this device burns out, and we're going to see how many turns it's good for. Then we're going to put the Alps encoder on, which is the one that's originally used in the TS990, and we'll see what... Now coming up to about 2 hours of cycling that Bourns encoder, and I'd like to point out how this Bourns encoder is made. I think you'll be very impressed when you look at the construction. Well, here we are again. It's 10:45 p.m., 5 hours later, and as you can see, my electric drill is still turning. And the speed right now, I've just slowed it down a bit, but it was actually doing 160 hertz on the scope. I don't know if you could see that. That's 145. So it's probably done about 100,000 turns in the past 5 hours. Remember, this is a 20, it's a 20 detent encoder, not a 24. But it still looks good on the scope. There's a little bit of noise, but that noise is normal because this switch is not filtered. If you look at the diagram of the Kenwood 990, there is a filter. There's a low-pass filter which would get rid of all that noise. So this switch is still good. By the way, I did reverse the direction of the drill periodically. So what I'm going to do is I'm going to run this drill all night and just see if it lasts another 8 or 9 hours. But at this point, I know that this switch will last over 5 years compared to the original Alps. Right now I've sped it up a bit, and as you could see, I'm running it at 246 hertz. Again, if you want to know what that RPM is, just divide by 20, and that's, revolutions per second. And I'll turn it down because you shouldn't really go that fast. The heat that you generate could burn out the switch. 140 is usually safe, and that's equal to about 7 cycles per second. So I'll leave that on. And we'll see when I wake up tomorrow if this thing is still surviving. But if it doesn't, I really don't mind, because this is a guarantee of at least 5 years. Just do the math. 140 cycles per second, divide by 20. I'm sorry, 140 pulses per second, divide by 20. And then that number into all the hours. Just divide it up and you'll see what it is. I guess I'm getting confused at this hour. So it's basically 140, which comes out to 7 cycles per second, and just multiply that by 60 again, so that's cycles per hour, and then times 5 for 5 hours, and that'll give you the number. Okay, well, this is the encoder wheel. I'm actually using my phone to take these pictures. I don't usually. And it looks like carbon that is silk screened on a wheel, but it's not. And that's the good thing about this control. And that's probably the reason why so far it's probably Been running for at least 60,000 turns at this point. I'm going to scrap it and I'll show you what they've actually done. It's quite ingenious. They've taken a metal disc and they've etched it, probably etched it in an acid or laser etching. And I'll just put it on pause for a second. I'll pull this disc off. I just can't do this with one hand. So I'm going to pause the camera for a second. So what you're looking at is the metal and plastic encoder wheel. So what they've done is they've actually placed holes, 20 holes, square rectangular holes in this disc, and they've pressed plastic from the back. You can see there's a plastic disc. I don't know how clear that is. I guess on a larger screen monitor you'll be able to see that. There's a black disc, and you can actually see I've peeled the disc, the metal wheel, away from the disc, so you could understand that the insulation that the brushes move over is quite good. It's a very good technique. I believe this encoder wheel is going to last for hundreds of thousands of uses, although it's only rated at 100,000. But remember, the Alps is rated at 30,000, and we're going to take a peek inside that in a little while. Well, good morning. It's 7:30 a.m. and we'll do some calculations in a minute. So this is what the scope looks like after a whole night of running. There's a little bit of noise in the pulse. You see some noise spikes in the square waves. But remember that there's no filter, there's no RC filter. In the Kenwood 990 there are two 100 ohm resistors with a 1000 puff, sort of a T-network, filtering out any noise from the switch as it ages. But I'll slow down the drill because it is turning pretty fast. And we'll notice I'm doing this with my hand. And you could hear the drill. It's probably turning at about 2 revolutions per second right now. And as you could see, those pulses are still perfect. They're usable. So if this were in a Kenwood 990, this product would still work if you turn the control at 2 revolutions per second. You could even go beyond that. That's about 3. As you can see, the counter is showing 67 hertz. So if you divide that by 20, that's 3 per second. And now, as a last confirmation, there were 2 white LEDs connected to this encoder as well. And so the object is that they're both off when the encoder is within a detent. And now I've taken the encoder. That piece of copper wire, by the way, was just soldered there so that when the drill wouldn't spin the encoder and just tear it off the wires. That's what that copper wire was for. Sorry for my poor camera work, but you'll see that I'll turn the encoder. And you could actually see that this encoder is still perfect. So let's do that. I'll turn off the backlight so it might be easier to see. The reason the light stays on sometimes is because I just don't have it in the detent. So turning it by hand, you can see that the scope still looks perfect. A few different views of the scope so you could sort of understand that this switch is still working fine. A We'll just turn it the other way. You can see the phase relationship. As I turn one way, the yellow leads the blue. That's the second trace. And then if I turn it the opposite direction, the blue leads the yellow. And the yellow lags. So that's how you determine direction of turning of that switch. But as you can see, that switch is perfect. Those are sharp edges. There's no filtering. And I'm now turning at a normal rate as if I were dialing across the 20-meter band. And remember, there is a little bit of noise, but that's normal. In fact, what I'll do is I'll connect a brand new switch, and I'll just show you these LEDs again. I'll solder in a brand new switch now, and we'll just compare the difference. As you can see, I've got a collection of the Bourns and the Alps switches. Used in the Alps are the ones used in the Kenwood, these black plastic shaft ones. The Bourns are much better built. If you look at them closely, there's a slab of steel. That's actual steel plate at the front, and that's keeping the pressure uniform. Whereas if you look at the Alps, it's only crimped tin, crimped metal, very thin and plasticky. So that could be why, one of the reasons why Bourne just keeps on ticking. So I'll just take one of these Bourne controls, since that's the one that I tested, and I'll put it on the scope as well. So what I've done is I've desoldered the encoder that was under test, and I soldered white wires to it. So the white wires are going to the one that's been running now for probably 12 hours. And the blue wires directly to the resistive network and the scope probes are the new control. So we're going to turn the old one, and I'll try to hold with my left hand the camera in front of the scope. So this is the old encoder. As you could see, I'm turning and pulses are clean. I have it on storage right now, so it delays for about 4 seconds. So you could just sort of catch the pulses. Notice how nice and clean they are. I'm turning at the rate of about 1 turn per second with my right hand. This isn't a very simple chore. Now we'll go to the old switch. Here's the old encoder. I mean the new encoder. That was the old one. As you can see, there's no difference. I'll turn it the other way. And we'll go back to the old one that's been running all night. Obviously the pulse width changes with the speed of my fingers turning this knob with one hand. So that's the old one, and this is the brand new unused one that I've just soldered in. So they're clean, they're identical. So there you have it. The calculation, this encoder was turned for 13 hours at 140 pulses per second. 140 pulses per second divided by 20. There's 20 increments on that encoder. Gives us 7 revolutions per second, and times 60, which is how many seconds in a minute, and times 60 again, which is how many minutes in an hour, and you come out at 25,000 revolutions per hour. And we ran it for 13 hours, and it didn't fail after 327,000 revolutions. That's a far cry from 30K for the Alps control. So you'll probably want to know where to get this drop-in replacement. The Bourns encoder is distributed by quite a few distributors in North America, Mauser being one of them. I purchased this from Mauser. They had it in stock, and price was really low. I think it was under $2. I'm sure of that. I just don't remember if it was $1.70 or $1.90. The Alps encoder was the same price, by the way. The Bourns encoder number, if you're going to look for it, it's a PEC, Papa Echo Charlie, 11L-4125, F like Foxtrot, dash S like Sierra, 0020. So you could look that up and order a few of them, because you can break them when you take a Dremo and you start to grind the shaft off. It is possible to damage them, and at that price, it's good to have a few backups. It won't hurt you. Obviously, once you put one in that radio, it'll probably last forever, since the encoder seems to last about 1.5 years. This one will last 10 times that, so I'll see you in about 15 years. See you later, and have fun with your 990. Bye for now. What I've done is I've run for the past 24 hours the original model of encoder used by Kenwood. It's an Alps controller made in Japan. And a couple of things that we should take a look at on this controller, on this digital encoder. And that is, first of all, the way that the tin casing that they've used. It's a very thin product, not rigid at all, and it uses 4 little tabs on the bottom to hold the plastic close to the body and allow the pressure of the wiper to run around the encoder wheel. Well, the first thing I noticed when I pulled my second defective one out of the Kenwood is that those little tabs tend to get loose. And so that takes the pressure off the wheel. The next thing is what I did, and I'm making this a little shorter than my last video, of the alternate solution, where I used a Bourns controller. And in this one, I ran this one for 24 hours as well. And I'm going to show you what the pulses look like after 24 hours. So we'll turn on that drill. Don't mind the jittering of the... I couldn't center the shaft on this drill because the Alps product has a shaft that's cut all the way down to the body. And there was no way I could shim it accurately to make it absolutely centered. But it doesn't really matter. I put it in a way that it's very flexible, and as you see, I've soldered that big thick piece of copper just to keep it from spinning, but at least it has the flex to move around with the wires connected. So this has been running for 24 hours, and look at these traces. The scope is having a hard time syncing, and I'm trying every way to do that. I'll actually change the triggering. And as you can see, it's the encoder's gotten extremely erratic. And I'll turn the drill off, and I'll just turn it manually, and you could sort of see what's going on. The blue trace is the B trace of the B connection. Second output of the encoder, and you could see it's not responding properly any longer. And if you look at the 2 LEDs on this encoder, I'll turn the light off and I'll spin the drill manually. You'll notice that sometimes you get 2 lights, 2 flashes of 1 LED before the second one goes out. It's the left LED, and I'll reverse direction. Going in clockwise, it seems to be a little better, but it's not right. The encoder is erratic. And looking at it on the scope, look at the blue trace. It's just completely defective.